Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the distance between 2 points. So we're going to start by calculating the distance between this point here and this point here. So some people who are visual learners might like to draw up the Cartesian plane and plot these 2 points. So if plotting the points, don't try to be super accurate. That's just a waste of time. We're just going to estimate where the points are. So x is negative 11 is about there, y is 12 is about there. The first point is around there. And for 9, negative 9, it's going to be around about there. What we are essentially calculating is the length of this line segment joining these 2 points. So we can calculate that using Pythagoras. We can make a right-angled triangle because the x and y axes are always 90 degrees to each other. So to find the hypotenuse, we need each of the shorter sides. So what's this distance along here? Well, to go from this point to this point, the x values increase from negative 11 to positive 9. So we've gone across 11 plus another 9. We've gone across 20 in total. 9 subtract negative 11. Similarly, to go from this point to this point, the y coordinate has decreased from 12 to negative 9. So we've gone down 12, down another 9. We've gone down 21 in total. Now, because we're dealing with distance, it doesn't matter whether you write this as a positive or a negative. So once we've done that, it's easy. We just use Pythagoras' theorem. So Pythagoras' theorem says C, which is the hypotenuse of the triangle, is just the square root of shortest side squared plus shortest side squared. So putting that in our calculator, we get 29. We just write U for units. Of course, you could have calculated this even if you didn't draw up the Cartesian plane. You can use this formula. This formula here is exactly what we did, just looks slightly different. So the hypotenuse of a right angled triangle is the square root of a squared plus b squared. A is how far you've gone horizontally along the x-axis. This b squared, this refers to how far we've gone up or down along the y-axis. So either way, we get the same answer of 29 units. All right, let's try a harder question. Distance between these 2 points is 34 units. We're going to calculate possible values of k. So I'm going to use this formula here. So I've got C, which I'm told is 34, is equal to the square root of, now, x2 minus x1, x coordinate of the second point minus x coordinate of the first point. Here, we've gone along 30, along the x-axis. Change in x is 30 squared. So that's our a squared. So what about b squared? How far have we gone from this y value to this y value? We don't know what k is, but we can write the distance as just k minus 14. So here we have c equals square root of a squared plus b squared. So this might look like a tough equation to solve, but it's really not. We're just going to square both sides. So 34 squared. Now, when I square this side, I just get rid of the square root. That's why I'm doing it. Square and square root undo each other. So I get 30 squared plus 30 squared is just 900. So subtracting 900 from both sides, I get 256 is equal to k minus 14 squared. Now, we just have to be careful here because you're probably tempted to square root, but you have to take the positive or negative square root. What I mean by that is there are 2 options here. Either k minus 14 can equal 16, because 16 is the square root of 256, but there's the other possibility that k minus 14 equals negative 16. See, if you have the equation x squared equals 256, there are 2 solutions. X can be positive or negative 16. So we're going to get 2 values for k as the question asked. So if k subtract 14 equals 16, well, you just add 14 to both sides and get k equals 30. On the other hand, if k subtract 14 is negative 16, again, we add 14 to both sides. This time we get negative 2. So they are the 2 possible values of k. All right, let's now look at the distance between points in 3 dimensions. So we're very familiar with seeing the 2-dimensional Cartesian plane. We can also have the Cartesian plane in 3 dimensions. Here we call the axes x, y, and z. So we have z and y perpendicular to each other, so x is supposed to be going in the other direction. So sort of like x is coming out of the screen, if you like. So all three of these axes are perpendicular to each other. So how would we plot a point? Well, if we have the point A, -3, 1, 4, it always goes in order, alphabetical order again. So x is first, y is second, and z is third. So what we do is we're first going to plot the point -3, 1. So we're going to go across to -3 on the x-axis, which is here. Now we need to go across to y equals 1. So y equals 1 is here, and all along this line, the y coordinate is 1. So what we sort of want to have is a rectangle or parallelogram looking shape like this. It will go like that. So the point is going to end up being about there. That is the point. X is -3, y is 1. So to find z is 4, we go up to 1, 2, 3, 4. So to find where it will be, we need to sort of have a rectangular prism. Here is the base of our rectangular prism. So we draw the line up here to z is 4. This line here should be parallel to this line here. I know I'm not a great drawer. It'll look like that. So the point will be there. And so I kind of have a poorly drawn there rectangular prism. That's how we plot points in 3 dimensions. So it's just like 2 dimensions, except there's an extra axis. And this is very important as you do more maths, because obviously we live in 3 dimensions. Not everything is in 2 dimensions and can be represented with a 2D Cartesian plane. All right, so let's find the distance from the origin to point A, which is this point here. So we're really looking for the distance from here, origin, up to there. So we can use Pythagoras' theorem in 3 dimensions. So remember the square root of x squared plus y squared plus z squared, that gives you Pythagoras in 3 dimensions. So here, the distance along the x-axis is just -3, so we'll put brackets around that. Distance along the y-axis is 1, distance along the z-axis is 4. So if you put that on your calculator, you get square root of 26, which is about 5.1 units. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.